Is it visible to you? Screen. Okay, the next topic is I already completed the embedded system. Okay, and general computing classification of embedded system, major application area of embedded system. Okay, elements of embedded system and core of the embedded system, and the difference between microcontroller and microprocessor, RISC, and Harvard and von Neumann. These topics I completed here. Then the next topic of your third module is sensor and interface. Okay, so here the sensor is nothing but it is going to generate the signals. Okay, that going to generate a signal that is nothing but electrical signal. Okay, from the physical quantity. Okay, from the physical quantity, what physical quantity is nothing but what? Your temperature, your light, your pressure. Okay, so yeah, means temperature, pressure, light, all these are all physical quantities. By using that physical quantities, it is going to generate the electrical signal. Okay, that is nothing but the output of the sensor is nothing but electrical signal. Okay, so that is we call that as a sensor here. Okay, and also here the sensor is a part of the transducers. Okay, the sensor is a part of the transducer. Transducers I will tell you in the after in few more slides. Like okay, the sensor is nothing but it is a part of the transducers. Okay, I will tell you. I will explain what do you mean by transducers after 5 to 6 slides. Okay, and here the sensor is nothing but it has to generate the electrical signal by using the physical quantities. Physical quantities is nothing but temperature, light, pressure. uh, Okay, all by using these physical quantities, it is going to generate the electrical signal. That is what we call that as a sensor, and it is also a part of the transducers here. Okay, the next. Okay, I'm going to discuss about the what I'm going to discuss about the instrumentation here. How it is going to generate the output. Okay, how it is going to generate the output here means general overview of my sensor or control system. Overview of my sensor here. Okay, so here as I told the physical quantity. Physical quantity is nothing but it may be a temperature, pressure, or light, or force, whatever it may be. It is your physical quantity. Using that physical quantity, the output of your sensor, it is going to generate as an electrical signal. Okay, electrical signal it is going to generate. But here the electrical signal, whatever it is going to generate, that is in terms of millivolts. Okay, so if I want to process that electrical signal, if I want to process that electrical signal, I have to check whether that is a conditional. I have to check the condition. Signal condition is nothing but, for example, the output of the sensor, it is generated from 0 to 5 millivolts. Okay, so if it is greater than 5 millivolts, then it is processed to the signal processing here. Okay, it is processed to signal processing. Signal processing, it may be in order to display the value, or in order to send a data output, or in order to recording. Recording is nothing but in order to store the value into the memory here. Okay, signal condition is nothing but the signal condition, it has to maintain the some threshold value. That is what we are going to use the signal condition. Threshold value is nothing but it will check if the output of the sensor it is able to generate greater than 5 millivolts or not. For example, let me take the output of the sensor is 5 millivolts. That is the minimum value it has to generate. If it is going to generate less than 5 millivolts, it will not consider that as a processing for the next level. Okay, so signal condition is nothing but it will check the condition. Let me Okay, here if it is, let me check, this is 5 millivolts. It has to greater than or equal to the output of my sensor. It should be greater than or equal to 5 millivolts. If it is true, if this output of my sensor is true, then it is going to allow in this signal condition for next process, that is called signal process. Okay, in the signal process maybe in order to display your data. Okay, to display the data. Okay, or in order to store the data. Okay, or in order to perform the output here. That is what we call that as a signal processing here. Okay, so that is what about the overview of my sensor or block diagram of my control system here. Okay, in order to check the electrical signal from the output of my sensor, in order to validate validate my signal from the output of my sensor. That is the block diagram of this system here. Okay, that is the block diagram in order to validate my signal at the output of my sensor here. Okay, so the next is here what I have to validate output of the sensor. What type of the signal? Output of the sensor is nothing but here it should be electrical signal only. It should be electrical signal only. Electrical signal is nothing but it may be voltage or current. It may be voltage or current. That is what we call that as an electrical signal here. Okay. And here come to this. Next is here whatever it is going to generate the sensor, as I told, the sensor is nothing but it is going to take it as a physical quantity as the input. Physical quantity as the input is nothing but what, as I told, it may be your maybe water energy or it may be air, nothing but your air or whatever it may be. Physical quantity is nothing but whatever it may be, your temperature, air, water, whatever it may be, it is going to sense that physical quantities and it is going to generate the output. Okay, sometimes the output of the sensor may be linear or non-linear. Linear is nothing but what? If the more input is there, it is going to generate more electrical energy at the output of my sensor. Okay, sometimes if it is less, it is going to generate less. Okay, sometimes the output of the sensor may not be linear. May not be linear is nothing but even if the quantity is increases, the output of the sensor it is not going to increase. Sometimes we call that as a linear, non-linear relationship. Okay, the output of the sensor may be having the relationship of linear or maybe non-linear, but it has to generate the electrical energy. Okay, and whatever it is, the output it is going to generate at the output of my sensor, it may be the electrical energy, but along with that, it is going to sometimes it is going to add the noise signal at the output of my sensor. The noise signal is nothing but the unwanted signal here. The unwanted signal is nothing but that is not required, that is waste signal. Okay, that is we call that as an unwanted signal. It is going to add with my output of my sensor. Okay, so that is we call that as a noise signal. Okay, that it is going to add. Whenever it is going to add with my output of my sensor signal, I have to validate my signal at the signal conditioning. I have to validate. Validate is nothing but what? Whether the output of my sensor signal it is greater than or equal to 5 millivolts. Just I take it as an example here. Okay, if it is greater than or equal to 5 volts, then it is going to process to the next level. Okay, that is we call that as a process to the next level. In order to next level is nothing but if it is greater than or equal to 5 millivolts, then only it is going to accept. If it is less than or equal to 5 millivolts, it will not consider at the signal condition. It will check the condition of the output of my sensor. Okay, based on that, it will consider and it will do the process. Okay, after the process, maybe it may be displaying or it may be recording. Recording is nothing but in order to store or in order to data output for that to send the output at the signal processing. So these are the what the process or the operation of my sensor here. Okay, these are the operations of my sensor. And additional here we can signal processing is nothing but here I can perform ADC or DSC operation. Nothing but analog to digital conversion or digital to analog conversion. That is what we are going to perform at the data output. Okay, here I am going to send the output to the ADC or DSC. Nothing but it has to convert from analog to digital converter or digital to analog converter. So these are the steps it is going to perform in the operation of the sensor here. Okay, that is what the operation of my sensor device. Okay, so this is what about, is it clear? Are you following me?
Yes, sir.
Okay, so the next is here I'm going to monitor. I have to get the stability in my sensor here. Let me go to the next slide. The same thing, whatever it is there. Okay, here in this system, whatever I'm showing in the system, that is circuit diagram. Okay, this is what the input, nothing but input is nothing but in the physical quantities, as I told. Okay, here this is the triangular representation. We call that as a comparator, as we studied in the op-amp. Op-amp is nothing but what we are going to use as a comparator here. And the amplifier is nothing but in order to increase the amplitude of my signal. Okay, amplifier here I'm going to use. And control device maybe your the actuator is nothing but your DC motor or your heater. Okay, all these are we call that as a controlled device here. Okay, here I am going to connect, this is my negative feedback. I'm going to connect the negative feedback because this is my system here, this is my open loop system. If I don't consider this one, let me, if I don't consider, if I don't consider for a few minutes, if I don't consider this one, okay, this will becomes the open loop system. Okay, this is becomes the open loop system. Open loop system is nothing but there is no feedback here. Okay, so there is no feedback here. That is what we call that as a open loop here. Okay, but whenever I'm going to consider the sensor and signal conditioning, we call that as a feedback. Okay, here what type of feedback I'm going to use? The negative feedback I'm going to use here. The negative feedback I'm going to use because of the stability of my system in order to get the constant output at my system here. That is what I'm going to use as a negative feedback here. Okay, so here what I'm going to do, just because of using the negative feedback, I have to get the constant output at my system. Okay, for that purpose, I'm going to use as a negative feedback over here. Okay, and here whenever the input is more, it is going to compare with the feedback signal here. Okay, whenever the input signal we also call that as a demand signal here. Okay, whenever the input and the output of my feedback circuit is going to different, it is going to generate the error signal here. Okay, what is the job of the comparator? It is going to compare the two signals. Out of that, if it is any mismatches, it is going to some output signal. That output signal I call that as an error signal here. Okay, so whatever the error signal it is going to generate based on the comparing of my input signal along with the output of my signal, so that it is going to generate error signal. That is, that error signal I am going to perform the amplification. Okay, amplification is nothing but to increase my amplitude of my signal here. Why I am going to increase the amplitude? In order to achieve the stability in the control device. Okay, control device is nothing but your the heater or your motors, actuators, all we call that as a control device. DC motor, heaters, because whenever you turn on your heater, water boiler heater, okay, what will happen? Suddenly it is going to supply the voltage from the input source to the your coil. Okay, obviously what I had to maintain the constant current, constant heat at my heater. So what I have to do, I am going to connect the sensor from the output of the device, that is open loop, to the feedback circuit. From the feedback, it is going to connect the comparator here. Output of the feedback, I'm going to connect with my comparator. Here, this is my input signal. Okay, input signal is nothing but my physical quantities. So based on the physical quantities, it is going to compare with my output of my feedback. Based on that, it is going to generate the error signal. That error signal, I'm going to perform the amplification here. Okay, why I have to perform the amplification? In order to maintain the constant heat in my heater. If I want to, if I have to generate constant heat, is nothing but I am going to get the constant output. That is nothing but we call that as a control device here. Heater, linear actuator, or DC motor. All these are all control device here. Whenever you turn on the power, obviously it increases the speed initially. After that, it becomes I'm getting stability. How get I stability? By taking some portion of the output and connect it to my feedback circuit. The output of the circuit I'm going to connect it to my comparator here. Based on the comparator, whenever the two input signal is same or equal, there is no error signal. Whenever there is no error signal, it will not perform any amplification. Whenever there is no amplification, it is the control device, it is going to achieve in the stability. Stability is nothing but I'm getting the constant output here. Okay, so that is what we are going to use this as a negative feedback in my device here. Are you getting?
Yes, sir.
Okay, so this is the simple operation of your the sensors along some simple operation. Sensor is nothing but what it has to measure the temperature, as I told. No, if I take it as your water heater is nothing but what? If I don't connect this feedback circuit, sensor and signal condition, if I directly apply my input signal, nothing but electrical signal, if I apply, if I apply electrical signal, what it has to do? Directly it will heat your water heater. It increases its water heater temperature. Obviously, whenever it is not able to stability, whenever it is not going to generate constant water heater as output, what will happen? There is no damage it will occur. So in order to maintain my system as a stability, I am going to use this as a feedback circuit. This is one example how I am going to generate the constant output at my water heater or it may be DC motor. This is the simple application how we are going to use the sensor in the negative feedback circuit here. Okay, so next come to this transducers. Okay, so next is the transducer here. Transducer is nothing but what? That is, it is going to convert from physical quantity signal into electrical signal. Nothing but sound energy, light energy, heat energy, air energy, whatever those are called, we call that as a physical quantities. All these are physical quantities. I have to convert into electrical signal. Again, from the electrical signal into a physical quantities, maybe sound energy, light energy, heat energy, air, all these are we call that as a transducers. Okay, all these are the transducers. Let me take it as an example. The loudspeaker. Loudspeaker is nothing but what? It is going to convert my electrical signal into a sound energy. That is nothing but that is the example for my transducer. Nothing but it is going to convert from one type of energy into another form. Here the input is electrical energy and it is going to convert as a sound energy in the loudspeaker. But in the microphone is what? Your sound energy, whatever the sound energy it is there, that is going to convert into a voltage or current energy. Nothing but it is going to convert from one type of energy into another form here. That is what we call that as a transducers. Transducers is nothing but it is going to convert from one energy into another form. That is what we call that as a transducers. Okay, So here the loudspeaker and microphone are complementary transducers. Why we call that as a complementary transducers? Because the loudspeaker here I'm going to use that is going to convert electrical energy to sound energy. But microphone, it is going to convert the sound energy into a electrical energy. That is, we call that as a complementary transducers. Okay, transducers is nothing but it is going to convert from one energy into another type of energy here. That is what we call that as a transducers here. Okay, so let us see here. Okay, as I told, this is the microphone is nothing but okay, microphone is nothing but your input transducer. Microphone is nothing but we call that as an input transducer. Why we call that as an input transducer? Because it is going to convert the sound energy into a electrical energy. Okay, that is what we call that as an input transducer. But what loudspeaker is an output transducer because it is going to convert electrical energy and a sound energy, nothing but audio system. That is what we call that as a output transducer as a loudspeaker and input transducer as my microphone. Okay, this is what about the transducers here. And the next is the input type of my transducers. Input type is nothing but we have. Let me analyze, let me explain the concept of input transducers. That is nothing but your microphone, thermocouple, potentiometer, all these are input transducers. Input transducers nothing but what? It has to convert the physical energy into electrical energy. That is what we call that as a input transducers. Okay. What are the input transducers? Input transducers is nothing but it is going to convert the physical energy into a electrical energy. That is what we call that as a input transducers here. Okay, so let me explain the working principle of the sound, temperature, and angular position. All these are all the input transducer here. Okay, so let me explain one by one in the upcoming slides. Okay, are you following me?
Yes, sir.
Okay, so here the input transducer is nothing but first let me take it as an example of my this microphone, nothing but your this one. That is your microphone. Okay, and here in this microphone, let me come into the what is there inside of my microphone here. Okay, inside of my microphone here. Okay, in the inside of my microphone, okay, it is I am going to explain the construction of my microphone here. Okay, how it is going to generate the electrical energy by using the sound energy here. Okay, and whatever you are seeing here, this is nothing but diaphragm. Okay, diaphragm. Okay, here using that diaphragm, we are going to wounded with the coil here. Okay, this is nothing but coil. The coil is wounded on the diaphragm here. And this coil, it is going to suspended inside with the magnetic. Okay, the magnet, it is going to suspended inside of your diaphragm coil here. Okay, so here this is what about the construction. The construction of my microphone is nothing but what here? That is the diaphragm. The diaphragm is wounded over the diaphragm is the coil is wounded over the diaphragm here, and the magnet, that is what are the magnet that is suspended inside of my inside the wounded diaphragm here. Okay, next how it is going to work? Whenever the sound waves, it is going to incident on the diaphragm. Whenever the sound waves, it is going to incident on the diaphragm. That diaphragm, it is going to change its area. Okay, so whenever it is going to change its area, based on that it is going to generate the electrical signal based on my voice signal here. Okay, what is happens whenever the sound waves it is false or incident on the diaphragm coil, what is going to happen? The diaphragm, it is going to change the area of the diaphragm, it is going to change, nothing but it is going to vibrate here. Whenever a diaphragm it is going to get vibrate, based on that the electrical signal it is going to generate here. Okay, that is going to cause the generation of the electric coil at the microphone here. Is it clear?
Yes, sir.
Okay, so this is the working principle of my microphone here. Okay, so this is the working principle of the microphone here, and this is the elaborated circuit diagram. This is what the sound diaphragm here, the diaphragm and the coil that is wounded on the diaphragm here, and it is going to suspended in the magnetic coil here. Okay, whenever the sound waves it is going to incident, it is going to vibrate my diaphragm. Based on that, it is going to generate the electrical signal. That is nothing but it is going to convert from my sound energy into electrical signal. That is what the working principle of my diaphragm here. Now we call that as also transducers. Transducers nothing but what? It is going to convert one energy into another type of energy form here. Okay, and next is the thermocouple. Okay, in this thermocouple, we have two junctions. One is called hot junction, other one is called cold junction here. The cold junction we also call that as a reference junction here. The cold junction is nothing but we call that as a reference junction here. Okay, and this cold junction, why we call this as a reference junction? Because this cold junction may be your 0 degree Celsius or room temperature, okay, or whatever, means nothing but it is a constant temperature. Wherever you kept, that is nothing but act as a reference temperature here. Okay, the cold junction is nothing but your act as a whatever the temperature it is going to measure, it is going to act as a reference junction here. Okay, whenever here, and also I am going to use two type of metal. One is called copper and constant tantalum. I am going to use a two type of metal, copper and constant tantalum here. Okay, here as I told, whenever it is going to apply the temperature at this hot junction, whenever the temperature it is going to apply to this hot junction, based on that, it is going to generate the voltage in terms of millivolts here. Okay, it is going to generate the voltage based on the temperature value in terms of millivolts. Okay, that millivolts I am going to add with my reference voltage. For example, this reference voltage is your 0 degree Celsius, is nothing but that will use the current temperature of this hot junction. Okay, if I make this reference junction as a room temperature, nothing but your 25 degrees Celsius, that this room temperature I am going to add with my hot junction, so that it will generate the corresponding millivolts. So that is nothing but it will generate the electrical signal at my output of my sensor or transducers. Okay, so this is the working principle of a thermocouple here. Okay, so this is the working principle of a thermocouple. Okay, and here the reference junction, it is going to I'm going to connect with the compensated cables. Okay, I'm going to connect this cold junction with the compensated cables in order to measure the temperature of the object, nothing but whatever the temperature of the hot junction along with the reference junction. Okay, that is going to generate a electrical signal based on this compensated signal here or cables. Okay, so this is the thermocouple transducer here. Okay, the next is potentiometer, or we call that as an angular position. Okay, so let me tell here, let me go to next slide. There is a brief description on that. Okay, see here in the potentiometer, nothing but we call that as an angular position. We have a three terminals, 1, 2, and 3 here. Okay, 1 and 3. The 1 it is going to connect to the positive voltage, and the 3 I am going to connect it to the negative terminal of my voltage here. Okay, and 2 is nothing but that is angular rotation. That is nothing but we call that as a wiper here. The 2 we call this as a wiper here. Okay, because this we call this as a resistive track here. Okay, we have to move this wiper on the resistive track here. What do you mean by resistive track? The resistive track is nothing but variation of the resistor value. Okay, the variation of the resistor value, it will generate the voltage here or the current. Okay, so here if I keep on vary this wiper from 1 to 3 or 3 to 1, I'm going to change that. I'm going to rotate this wiper in the clockwise direction or in the anti-clockwise direction. Based on that, it is going to generate the electrical signal here. Okay, so that is what we call that as a potentiometer or angular rotator, angular wiper here. Okay, so this is nothing but if I rotate, if I am going to rotate my wiper from minimum to maximum, what happens? The voltage keeps on increases. Whenever the voltage increases, obviously current is also increases. So nothing but this is we call that as a linear law here. Okay, here percentage position of your wiper. If I keep on vary this wiper from minimum to maximum or maximum to minimum, it based on that it is going to generate my electrical signal here. That is what we are going to see, the linear relationship between our position of your wiper, how we are going to vary. Based on that it is going to generate the voltage. Voltage is on y-axis and wiper position on the x-axis here. Based on that, if how we are going to vary this wiper, based on that it is going to generate the electrical signal. That is what we call that as a potentiometer here. Okay, or we call that as an angular position here. Okay, this is nothing but this is input transducer. We also call that as a input transducer here. Okay. So here, as we seen, what are the input transducers here? Input transducers, nothing but your microphone, nothing but dynamic microphone, thermocouple, or potentiometer. Okay, all these are your transducer. Why we call that as input transducer? It is going to convert the physical quantity into a electrical quantity. We call that as a input transducer here. Okay, and whatever I explained, all that is given in this description here. Okay, diaphragm is attached to a coil that is suspended in a magnetic field here. Whenever the movement of the diaphragm occurs, nothing but the sound wave, it is going to incident on the diaphragm. It is going to generate the current in the coil. Nothing but electrical signal in the coil here. Okay, and in the thermocouple, we have two junctions. One is called hot junction and the other one is called reference junction. Okay, so whenever there is a difference between that two junctions, it is going to generate the electrical signal. That is, we are going to measure at the electrical signal in terms of millivolts or milliamperes. Okay, that generated signal I am going to add with my reference signal here, reference junction here. Okay, that is what about the thermocouple here. And potentiometer, rotary potentiometer or angular position, by varying of the wiper, it is going to generate the electrical signal. Okay, so these are all we call that as a input transducer here. And let us see the output transducer. Okay, output transducer is nothing but what? Loudspeaker, heating element. Okay, all these are output transducer. Output transducer is nothing but what? It is going to convert the electrical signal into a physical quantity. That is what we call that as an output transducer. Output transducer is nothing but what? It is going to convert electrical signal into a physical quantity. Let me explain the working principle of my loudspeaker. As you seen in the diaphragm, the same concept you are implemented in the loudspeaker also. Okay, this is the what the diaphragm. The coil is wounded. This is nothing but the diaphragm is the coil is wounded on the diaphragm and it is going to suspended in the magnetic coil here. Whenever the electrical signal it is going to appear, the diaphragm it is going to vibrate. Whenever the diaphragm it is going to vibrate, based on that it is going to convert the electrical signal into a sound energy or physical quantities. Okay, that is quite opposite working principle of a diaphragm here. Are you getting my concept?
Yes, sir.
The quite opposite principle of a microphone in the loudspeaker. The diaphragm, that is the wounded coil, that is we are going to suspend it in the magnetic field. Whenever the electrical signal is going to incident, the diaphragm will get vibrate. Based on the vibration, it is going to generate the physical quantity, nothing but sound energy. It is going to generate at the loudspeaker here. Okay, next is the heating element, nothing but what? Your water heater. Okay, in the water heater, what? If you are going to apply the electrical energy and it is going to generate the temperature or heat energy. Is it or not? In the water heater, what is the principle? If you are going to apply the input as a electrical energy and it is going to convert that electrical energy into heat energy here. That is what we call that as a heating element here. Okay. And here again in the potentiometer, nothing but we call that as an angular position. Nothing but again here by using this potentiometer, I am going to generate the constant speed at my motor. Okay, as we seen in the rotary potentiometer. In the rotary potentiometer, if I change the position, okay, at the fixed position, it is going to generate the fixed voltage. For example, your regulator, fan regulator. Fan regulator is nothing but what? You have 1, 2, 3, 4, 5 speed. Okay, you have numbers. If you keep the regulator at the number 1, it will turn your fan speed is very low. If I keep on increases my regulator speed, that is 1, 2, 3, 4, 5, nothing but what will happen? It will increases your fan speed. So nothing but the example for your angular position at the output transducer is nothing but what? That is also a triangular position. That is also a potentiometer. The same potentiometer I am going to convert the the electrical energy into a physical quantity, nothing but speed of the fan here, regulator. Okay, if I keep my speed of the fan is 1, what will happen to a fan speed? It is low. The same regulator, if I increase to 5, what will happen to a fan speed? It will increase your fan speed to fastest. So nothing but again the same potentiometer I am going to use as a output transducer also. The same potentiometer I can use as a input transducer also. Okay, so potentiometer is nothing but what? I can give it as an example for your input transducer. I can give it as an example for also output transducer. That is what we call that as a input and output transducer. Is it clear? Are you following me?
Yes, sir.
Because the same potentiometer I can use as an input transducer, the same potentiometer I can use as an output transducer also. So that is what we call that as a angular potential. That is nothing but where we are going to fix the position. Okay, using this rotary potentiometer. Okay, so this is what up to the transducer, and in the next class I am going to discuss some more topics related to the sensor here. Okay, is it clear? Any doubt in this?
No, sir. No, sir.
Okay, so if you have any doubts or any confusion, you can ask. Okay, or else you can join for next session.
Thank you, sir.